Hi everyone, in this video we'll be learning how we'll be seeing if a set of vectors containing the zero vector forms the basis for a vector space. So what does it mean by the zero vector? It's just like 0, 0 all the way 0. So how do we do this? Again, how do we know that a vector will form the basis of a vector space? First we see if they are linearly independent and if it spans the vector space. So if the set of vectors both are linearly independent and it spans the vector space, this means that the set of vectors containing the zero vector will form the basis for a vector space. So now we have an example here. Okay, so for this we have three vectors. So now let's do our step 1 first. So we want to see whether they are linearly independent. So we can write a linear relationship between these vectors in this form. So just like what our previous videos on how they are linearly independent, we will write as C1 1 2 3 plus C2 3 2 1 plus C3 0 0 0 equals to the zero vector. So now we have 3 rows, so we have the zero vector in this form. So now we can write our augmented matrix having the matrix coefficient of these three vectors and the matrix of constant, which is this. So therefore we can write it in this form: 1 2 3 3 2 1 0 0 0 0 0 0. So this is our augmented matrix, and now we are going to reduce it to reduced row echelon form. So let's continue from here. 1 2 3 3 2 1 0 0 0 0 0 0. So this is row 1, row 2, row 3. So now first we reduce it to row echelon form first. So now you want to eliminate for the first row the entries in the first column in the second and third row. So you get minus 2 times of row 1 plus row 2. And now to eliminate the entry here, so it's minus 3 times of row 1 plus row 3. So hence you get something like this: 1 3 keep the first row constant, 0 equals to 0. So now for this, you get minus 2 times 1 equals to minus 2, minus 2 plus 2 equals to 0. And for this also, minus 2 times 3 equals to minus 6, minus 6 plus 2 equals to minus 4. So for this, it will be 0, and for this, it will be 0. And now for the third row, to eliminate this entry here, so it's minus 3 times 1 equals to minus 3, minus 3 plus 3 equals to 0. Here for this one, so it's minus 3 times 3 equals to minus 9, minus 9 plus 1 equals to minus 8. So for this, it will be 0 and 0. So now you want to eliminate the entry here, this one, the entry in the second column in the third row. So now you add, this is row 1, row 2, row 3. So hence minus 2 of row 2 plus row 3 to eliminate this minus 8. So hence keeping row 1 and row 2 constant, 0, 0, 0, minus 4, 0, 0. So for this, it will be 0 because minus 2 times minus 4 equals to 8, 8 minus 8 equals to 0. This will be 0 and 0. So now we can make the leading entry into 1 for the second row. Therefore, you get 1, 3, 0, 0, 1, 0, 0, 0, 0, 3, 0, 0, 0. So now we can make it to reduce row echelon form. So hence we can eliminate this entry here. Let's do some cleaning up. So hence so let's continue from here. So now this, so what do? We can invert upwards now to eliminate the entry above 1 here, which is 3. So we add minus 3 times of row 2, add to row 1. So now we keep this. So 0, 1, 0, 0. And now for this, so 0 and 0 will be 0. And then now for this, minus 3 times 1 equals to minus 3. Minus 3 plus 3 equals to 0. And for this also, minus 3 times 0 equals to 0. 0 plus 1 equals to 1. And this will be 0. So from here, it's already in reduced row echelon form. So now, we cannot, as you can see that, you can tell that this system has infinitely many solutions. Hence, you can say we cannot find the value. We cannot find an exact value for. Here we can see that C1 equals to 0, C2 equals to 0, but C3 can be any real any values. So we put it at this form. So hence we can say that the system has infinitely many solutions, and from here we can see that the relationship among these three vectors is therefore from these C values not a trivial one. Therefore, they are not linearly independent. Therefore, step 1 fails. So from here, we cannot proceed with step 2 and step 3. So this one, we cannot carry on because step 1 shows that they are linearly independent. So therefore, these do not form a basis of a vector space. So now we have, so therefore this one is no, no. Sorry about that. No. So this cannot. So therefore we have already come to the end of this lecture. If you have any questions, you can take a look at my previous videos regarding linearly independent and spamming so that you can understand this. You can also drop me a comment so that I will reply to your comment as soon as possible. Thank you very much and have a nice day.